Mhm.
Okay, so if k is less than 0, and it's okay to actually like write something if you're not sure what to do here. Give me just a moment, please.
Okay.
All right, I'm back. So for example, it's okay to say like, well, what is like negative 2x squared? What does that do?
Mhm.
And like this would be like 3x squared.
Yeah.
Okay, but it could be that it's it could also be that this is negative 2x cubed, or that this is 3x cubed. And so like it's like these are the possibilities for these graphs. So like let me come
Mhm.
down here and try to summarize here. So if let's look at if n is even for k less than 1, or let's do k greater than 1. For k greater than 0, it's gonna start high and end high. Like we don't know what's gonna do in between here, but it's gonna do this.
Okay.
And if k is less than 0, and that's why I'm a little surprised they're giving you like lines there, but it starts low and ends low because of that.
Okay.
So then if it's odd, then there's two other graphs to consider there as well. So if n is odd, for k greater than 0, it starts low, ends high, and you can think of like a cubic doing that.
Mhm.
But if k is less than 0, it starts high and ends low. So that's, I mean, that's in short how we answer this. Is like these graphs.
Mhm.
It's like the end behavior. You're trying to figure out what end behavior does.
Got it.
K, when k is from 0 to 1, this is a because it's on the outside. It's on the outside. It's a vertical, either a stretch or a shrink, and it's a shrink for 0 less than k less than 1, and it's a stretch if k is greater than 1.
Okay. Got it.
Is that okay?
Mhm.
All right. So that takes care of that, I guess.
Yeah.
So let's keep going here. Oh, and then next is a matching thing. Oh, and there's 2 points. So, there's a lot here. Okay, I guess I might need to move faster. I was thinking this was just one page, but it's not. Okay. Got without using a grapher, match the graphs their function listed at the right. Okay, so go with ones you know. So like negative 2x to the 4th. That's gonna start low and end low.
Mhm.
That's this, like this one on the right here that we looked at earlier. So that is probably D.
Yeah.
Okay, so I'm gonna double I's. And then just plain old x to the 4th, that's gonna start high and end high. So that's probably that one.
Mhm.
Okay. And then which one is V, do you think?
Probably E.
It's like a, yeah, it's a, so that one, well, actually I take that back. So this is probably IV. So the because it's like this, it's a vertical. Yeah, I guess that probably is V. That
Okay.
does make sense to me. All right, and then these other ones are a little bit harder to do. The x to the minus fourth, this I is 1 over x to the fourth, and the other one is just a stretching of that. So my guess is like this is probably 3, and this is 1.
Okay. Mm,
All right, if we need, I guess we need to move a little faster through this.
Yeah, we can move on to the next page.
2, 6. Okay, this is just like, these are, I see. Okay, let's try and do these as quickly as possible. These aren't really helpful for your exam unless your exam is very theoretical. So,
Yeah.
okay, tell whether or not the function is a function is a rational function. Explain. So, oh my gosh, these all require. So the one that for sure is this one down here.
Okay.
Even though it's got the roots, it's because it's a polynomial over a polynomial. Notice that it's the square root of 5 times x. It's not the square root of x. And the square root of 17 is irrelevant.
Mm-hmm.
Okay, but like A is not because of the square root. C is not because it's got number to a power.
Okay.
And then the B there, we would have to like simplify. It may also be it may end up being that. So it's like a bit of work, but notice, yeah, so this one, it's kind of looking like it is, but
Yeah.
but there's a lot going on here. So I want to say probably, I mean, we'd have to actually simplify that.
Okay.
So it might be more helpful to move on to 2. So give an example of a rational function in which the zeros of the top are not the zeros of the bottom. So what they mean by that is like x minus 3 has a 0 at 3,
Mm-hmm.
and then x minus 4 has a 0 at 4.
Yeah.
Okay, so like anything like that would work.
Okay. All right, we can move on to number 3.
Okay, so then give an example of a rational function in which the zeros of h of x are not asymptotes of k of x. Okay, so the point of this is that the asymptotes occur on the bottom.
Mm-hmm.
So, I mean, you could say like x minus 2, that has a vertical asymptote at x equals 2. But
Yeah.
the zeros of h of x are not asymptotes. So I'm sorry, that is slightly more different. They're not asymptotes. So the way this is an asymptote unless in the numerator you have the same factor.
Yeah.
And now it's a whole.
Mm-hmm.
So we need to make this a little bit more complicated. So we'll say x minus 3, x minus 4, so that's still rational. But because these cancel, It's a whole, not an asymptote.
Got it. Okay.
Okay, so the 4 is this classic, like, what are the three possibilities for degree of the numerator, degree of the denominator?
Yeah.
So it has a horizontal asymptote if A, which is the degree of P of X, so this has degree A and this has degree B. It has a horizontal asymptote if it's less than or equal to B.
Okay.
When they're equal, it always becomes Y equals 0.
Yeah.
And the x-axis is an asymptote of F of X. Oh, that's the one when they're equal. I see. That's kind of this must be an old book or thing. Okay, so they're less than is when there's a horizontal asymptote. It's the x-axis, which the x-axis is Y equals 0 if they're equal.
Got it.
And then you should find the end behavior, which is the slant asymptote, if A is greater than B.
Okay. Got it. All right.
We're not going to get through all of this, so I would really recommend we prioritize what we do.
Okay.
Like the sample chapter test, if that's important, we should do that like starting right away.
All right. Let's just skip the 2.8 because I think I can do that, and look at 3.1,
Okay.
the back page, and then let's move on to the chapter test.
Okay. All right. So I'm snipping in 3.1 questions 1, 2, 3, and 4. Okay. A times b to the x is an exponential function in x where a and b are number. Yeah. This is weird. I don't know what to put in some of these. I mean, a cannot be 0. Okay. B is not 0 either. Usually A and B are positive, but not always. They're integer. I don't have any idea what you can put there. Okay, so expression x where A and B are don't know. B is B is the no idea.
I can ask my teacher. It's
No
okay.
idea what they want here. But what this is saying is when x is 0, anything to the 0 power is 1, b to the 0 equals 1. So that's why it's just A.
Got it.
Okay. All right. So number 2, let f of x equals 5 to the x. Okay. And g of x equals f of negative x. So we're going to put negative x in over here. So g of x equals 5 to the minus x, which can be written as 1/5 to the power of, or 1 over 5 to the x. But because 1 to the x equals 1, you can actually write this as 1/5 to the power of x, because that x is going to apply to both the top and the bottom. So the answer here is, see that a, this is the a, is this right here. So 1/5 the power of x.
Got it. Okay.
Okay, so now let's go to the next one. The domain is all reals. So they're talking, I guess, about this one, and that is true. That is true because the graph of this thing, if you look at it, it goes like that.
Yeah.
They have a discontinuity at 0 that is false. That would be like a hole or something. So this is important. A greater than 0 and B greater than 0, the function is an exponential growth function. So like, let's pick some numbers there. Like, let's say it's 2 times 3 to the x. This is a growth function, so that's
Mhm.
true. The graphs are symmetric about the origin. That's false, because you can see here it doesn't look the same on the left and
Yeah.
the right. All right, so then the limit as x goes to infinity, what do they want there?
So like
One,
it's just infinity.
let me see if there's more to it here. I don't know what this is. Oh, E. Oh, E. E is the limit of yeah, I don't actually know, but I think this is X here, but you should just figure out what goes in there.
Okay.
All right, let's do the next grouping. And this is you've got this for a grade, or this is something that has to be done for tomorrow. Is that right?
Yeah, but I have time to like go in and ask questions, so it's okay.
Okay. None of this is very useful for actually doing problems.
Yeah.
Okay, so all right, this is the logistic equation. Okay, it's used to model like certain populations. Is a logistic something equation. I don't know what to put there, but as x goes to infinity, so you might think, well, how can we do this? Well, b to the x, that also goes to infinity.
Mhm.
So 1 plus infinity is infinity. A little c, which is some number over infinity, is 0.
Okay.
Oh, and b less than 1. I'm sorry, I missed that. That's important. So I take back what I just said. So if b is less than 1, you can think of this as c over 1 plus a times like -3 to the x.
Mhm.
Oh, I'm sorry, positive. So no, it's not negative. It's like 1/2. Be like 1/2 to the x. Okay, so that's different. As x goes to infinity, 1/2 to infinity becomes 0. 1 plus 0 is 0. So this just goes to c,
Okay.
which is known as the blank to growth. Maybe it's probably like decay.
Okay.
And this is maybe decay, I don't know, or growth. I don't know, it's probably one of those words there. If b is greater than 1, f of x is a logistic growth equation. Now, maybe it's a decay equation. I really don't know. It's one or the other here.
Okay.
And then, so this is what I was actually telling you to begin with is if it's like 2 to the x, that goes to infinity. 1 plus infinity is infinity. C over infinity is 0. So that makes more sense. Yeah, so probably some combination of growth and decay for that.
Okay.
All right, let's see if we can do 6. You want to go for the ones that kind of maybe you've seen before, like e to the x goes like this. So e to the minus x is a flip that way. So this is letter A.
Okay.
And I just showed you what e to the x looks like. So e to the 2x is going to look something like that. These aren't scaled well, but you can see that that's probably B. And then these are really like the same graph to me. So I don't really know how you're supposed to choose between them, but you're supposed to choose between them. So I don't know that it matters. C and D, we'll say. They look exactly the same to me. I
Okay.
guess this one's slightly lower, maybe that. And so you can figure that out by putting 0 in for x. So this is, if you put 0 in for x, it's 1 over 1 plus e to the 0, which is 1. So this is 1/2. This is 1 over 1 plus 2 times 1/3 to the 0. It is 1/3. So which is smaller? Looks like that one's smaller.
Mhm.
So 1/3 is smaller than 1/2. That's probably D, and that's probably C.
Okay.
All right, let's go to your sample chapter test.
Yeah.
And start with number 1. Okay. Use transformation to explain how to obtain the graph of this thing from this on the right. So this is the first transformation, the -3, the 2 is the second, and the -5 is the third.
Okay, so it's right 3.
The 2, because it's greater than 1, is a vertical stretch, and because it's on the outside by 2, and then down 5 because of the -5.
Mhm.
Let's do the next one. Identify the vertex and the line of symmetry of the function. So when it's in this form, ax squared plus bx plus c, the vertex x coordinate is minus b over 2a. So it's minus a -2 over 2 times 5. So that's 2 over 10, which is 1/5. So that's the x coordinate. That actually gives you the line of symmetry. It's x equals the h value of the vertex. It's x equals h, so it's x equals 1/5. But we
Okay.
still have to find the y value. So to find the y value, unfortunately, you have to put 1/5 back into this. So it's 5 times 1/5 squared minus 2 times 1/5 plus 7. We might want to change 7 to like 35 over 5 because we're going to probably combine it with some other stuff here. So this is 1 over 25 when you square it. 1/5 squared times 5 becomes 1/5 minus 2/5 plus 35/5. So this is negative 1/5. So it's 34 over 5 as your y value.
Okay. Got it.
Okay. All right. So the Minor Diner serves all you can eat lunch for $6. An average of 90 luncheons are sold per week. Market survey indicates that for each 25-cent increase in the price, the number of customers will decrease by 3. Okay, so there are there's actually like the revenue is price times quantity,
Mhm.
and the current price is $6. What are they trying to do here?
Increase it by 25 cents.
Yeah, so we'd say plus 0.25x. And then what is the current quantity?
90.
And then what's going on with it? It goes down by
3.
yes. So it's almost always the case that one is plus, one is minus. And this is your revenue equation.
Okay.
So that's this first part. Now your part B is if it was written this way, what is the vertex? You could probably do this. Okay, so to get the vertex of this, you have to FOIL this. So 6 times 90 is 540 plus 6 times -3 minus 18x. 90 times 0.25, so that's a quarter of 90. So it's like whatever that is, 90 over 4. Losing. So it's like 2250. That seem right?
Yeah,
Maybe.
I think so.
Yeah, that looks right. And then minus 3/4 or 0.75 x squared.
Okay.
So you rewrite this minus 0.75 x squared plus 4.5 x plus 540. And you need the vertex. So your vertex is your A is minus 0.75, your B is 4.5. So your vertex is minus B over 2A. So 4.5 over 2 times minus 0.75. Oh, that's negative. That's why I wasn't working. And then so this ends up being 3. So X is 3.
Okay.
X is not the price. It might feel like that's the right answer, but it's not. X is 3. But price is this 6 plus 0.25x.
Yeah.
So your price is 6 plus 0.25x. We know that x is 3, so it's 6 plus 0.25 times 3, which is 6.75.
All right.
Revenue is actually putting x back into this thing here. So we know the first part is 6.75 and x is 3, so it's 90 minus 3 times 3, so it's times 81. So I don't know if you have a calculator. I go grab one too.
Yeah, I can do it.
So that'll do it there. That's a business calculus question that they do before they know the calculus. It's what you see in business classes.
Mm-hmm.
Seems out of scope here, but this test is you know. Let's see here. So choose a viewing window. Okay. All right. So do we actually want to graph this, or do you want to do this on your own? Use Desmos. What would you like for this?
I'll just do that on Desmos. Would be
Okay.
super easy. So we can just move on to 5.
Okay. All right. 5 is kind of requires calculator. I know it says to do it algebra. Oh no, I'm sorry. Actually, we can do this. Okay, so the first thing is that, do you see that there's an x squared that goes into each one? And you
Mhm.
can factor that out. So it's 2x squared minus x minus 6. So now you got to factor this inside one, maybe, if it works.
Can I?
Maybe. Yeah, so this is 2 and this is 3. Yeah, that'll do it.
Okay. So zeros.
So the zeros are at 0, -3/2, and +2.
Got it.
Okay, so the end behavior the end behavior is based on the power term or the leading term. None of this other stuff matters.
Okay.
So the graph of this thing is starts high, ends high. So
Okay.
we can say something like, that we can say as x goes to negative infinity, so that's over here, f of x goes to positive infinity.
Mm-hmm.
And similarly on the right, as x goes to positive infinity, f of x goes to positive infinity.
Got it. Okay. Oh, great. Now I get to divide.
Yes. So I guess I kind of know where you are now in this class. I think, although like some of the stuff doesn't seem to connect, but
It's
this
all over the place.
a little bit, yeah. So say that. So this one is like where I always say you will get a problem on an exam where you have to do it with like long division and then
Mhm.
synthetic division, but this one doesn't say that. It actually just says to divide. So we can use whatever we want. When I'm gonna use synthetic
Oh,
division.
okay.
But be advised on the exam, it
If
may
it
tell it,
says long division.
yeah, then you have to do it.
Mhm.
So the reason there's a 0 there is there's a missing cube term in there. So you bring the first number down, multiply 3 times 4, add, multiply. Wow, this isn't working out real well. Multiply 152, I think. That sounds reasonable. Add 155, multiply. So it's like, let's see here, 160 times 4 is a 640, and then you subtract that, it's like 620, 625, something like that. Whatever this is your remainder.
Lovely.
Yeah. Your quotient is this stuff. And remember, it goes down by 1. So this is x to the 4th. This is now 3x cubed plus 12x squared plus 38x plus 155.
Okay.
Let's take a look at 7. Find a degree 3 polynomial with real coefficients whose leading coefficient is 5 that has -2, 1, and 4 as zeros. So this corresponds to x minus -2, x minus 1, and x minus 4. It's always x minus the 0.
Uh-huh.
So this first one will become x plus 2, then x minus 1, then x minus 4. Now there's usually like an a here, but they're telling you what a is. They're telling you that
5.
it's 5. So this is 5 here. This does not say to put it into standard form. So standard form is when you multiply everything.
Mm-hmm.
This is called factor form, and it doesn't say, it doesn't say to do that. So I would just
Leave it.
leave it.
That.
Yeah.
Lovely.
And then claim ignorance if you have an issue.
Okay.
Yeah. Advice is worth what you pay for it. 9 is a calculator problem, pure calculator problem. So if you're okay with that, I can show you how to do this in your calculator, or if you already know, we can skip it.
Yeah, I already know how to do that, so we can skip that.
Only thing I'll mention here, I'm not going to do it, is that x equals 0 is 1970. So this is really 2, 5, 8, 10, 13, and 19.
Okay, thanks.
How do you know if it's a good fit? You want r squared to be as large as possible, and it ranges from 0 to 1. So you want it to be closer
Mhm.
to 1
To
if
1.
possible.
Got it.
10 is done in Desmos.
Okay.
And we'll go back if we got time, but let's just keep going here. How many zeros will 10 have? Do you see that on your page, or do you want me to snip it in?
I see it.
It's the degree. It has at most
6.
Six, but here's what could happen is, because it's gonna start high and end high, it may not cross 6 times because it'll either have 6 for 2 or 0.
Mm-hmm.
So the ones that it doesn't have are the not real ones. So like, let's say it only has 4, that means there's 2 that are not real.
Okay.
And you're not trying to find those, but just don't, don't. I mean, I've seen where, you think, oh my gosh, I can't find these things, but they just don't exist.
Yeah. Okay.
All right, let's look at
12.
12. This one is a lot like 8.
Mm-hmm.
With a little wrinkle. And the minor change here to this one is that complex roots come in pairs.
Yeah.
So this is a complex root. So that you're supposed to know that it's also 4 plus 5i.
Mm-hmm.
This one does say in standard form. So that means you do have to multiply this out.
Okay.
So it's x plus 2, because it's minus, it's really x minus minus 2. X minus 3. Okay. Then this one, these are a little bit, this is the kind of the right way to write it. On a test, maybe you can just distribute that negative real quick to get it, but then it's also x minus 4 plus 5i.
Mm-hmm.
X minus 4 minus 5i. And then you have to multiply these out, and then multiply the results out.
Okay.
Would you like us to do that?
Yeah, let's do it real quick. So it's
Okay.
x squared plus
Okay.
5.
So the one on the right, I want to make some comments about, because it's very important that this be clear. So just let me know when you get done with this part. If you're okay with that. So we're, the approach I'm going to do is take x and multiply by each of these. And I'm making columns for things that are like so. And that'll become apparent here for the next. So minus 4 times x goes in this column. I'm not going to write it out horizontally. I know that's what you might have done, but you'll see why this is better. So minus 4 times minus 4 is 16, positive 16. Minus 4 times minus 5i is plus 20i. 5i times x is plus 5xi. 5i times minus 4 is minus 20i, and then it's minus 25i squared. So notice anything with an I term cancels.
Yeah.
And you might be saying, what about this last one, Matthew? Well, I squared is -1. -1 times -25 is 25. So it actually really goes here. And it ends up being x squared minus 8x plus 41. And you still have to multiply these. So x to the 4th. Or you can go to an online thing and it'll spit out the answer for you, but we'll keep working on this. Okay, and then it's minus x cubed minus plus 8x squared minus 41x, and then minus 6x squared plus 48x minus 246. So x to the 4th minus 9x cubed plus 43x squared. Is that an 8? Yeah, it's an 8. Plus 7x minus 246. Don't know how you're supposed to do all that in the space provided, but
yeah. Okay. All right, last one.
The last one is really tough to do if you don't know one of the zeros to start with. And if this were on a test without a calculator, you would have to use the rational zero theorem. You remember this from class where you write the factors of 65 over the factors of the leading coefficient?
Yeah.
So this one is 5 plus or minus 13. And supposedly one of these will work. Well, it's all over plus or minus 1. So supposedly one of these will work. There's no sign changes, so it's not positive. That's another thing. But like if you have a calculator grapher thing, you would graph this first. Otherwise, you're just guessing. And I'm not gonna guess because we have time here that's important. But the truth is, it would take you a long time to figure out that -5 is a root.
Yeah.
And so I would beg you and plead with your instructor to not to allow you to use some technology to find the first root. Because when you find the first root, it reduces this down to a quadratic, because we're going to use synthetic division here. I've already written the coefficients, brought the 1 down. -5, 4 times -5 is -20, 13, -65, 0. So when this is 0 here, when the remainder equals 0, you know that it's a root.
Okay.
And then this becomes x squared plus 4x plus 13. And you try to factor, but factoring doesn't work. So that leads to quadratic formula. So x equals minus b plus or minus the square root b squared minus 4ac all over 2a. So it's -4 plus or minus the square root of 4 squared minus 4 times 1 times 13 all over 2 times 1. Okay, so let's see what we got here. This becomes -4 plus or minus, inside here ends up being -36 all over 2. So it's -4 plus or minus 6i over 2 over 2. So it's -2 plus or minus 3i. That plus the other one are your roots.
Okay. Got it.
So that closes out that. We can go back and do the part of 2.8 that we did not cover, if you would
Okay.
like, or something else.
Yeah, let's just go back to 2.8. I think we'll have time for like 1 or 2 more questions.
Sure. I'm snipping in question 1 now.
Okay.
And we can try to answer it. God, students will be able to. Okay, so determine 4 possible polynomial inequalities that could be solved using the graph of what? Determine the 4 possible polynomial inequalities that could be solved using the graph of that. Give the solution of each.
What is that even asking?
I'm not sure, but I'm gonna show you what I guess is reasonable here to maybe do. So there's a 0 at 2, -3. There's one at 2, there's one at -3, and there's these are at plus or minus the square root of -15, which does not exist.
Yeah.
And then, what's the end behavior here? So it's x to the 1 times x squared times another x squared. So it's an x to the 5th. The leading is 1. So it starts down here and ends up here, and
Yeah.
it touches though right here.
Okay.
Because of that 2 on the outside. The value at 0, we can figure out it's -2 times 15 times 3. It's way down here. So essentially this comes up, looks something like that.
Okay.
I have no idea what this is asking for. So because I was thinking it would say like, where is it less than 0, greater than 0?
I don't know what a polynomial inequality is.
Yeah.
I'll just ask about that.
Okay. Let's try 2. Let's see if we can make some more sense here of this. If a 4th degree polynomial has 2 zeros, each of multiplicity 2. So here's what that could look like. X minus 3 squared, that's a 0 at 3, and it's got a multiplicity of 2, times another 0. Let's say it's at -5. This is your second 0, something like that. And here's what that means graphically. It means that there is, it touches at -5 and at 3. It either touches, or touches. But we have more information here. It says, if the limit as x approaches infinity goes to infinity, that means this. This part right here means this right here. It means as you go to the right, the function goes up forever.
Yeah.
So that means that it touches, does something in here, touches, and it has to go back up because it's a 4th degree. It has to start high and end high, or start low and end low. Is the function ever below the x-axis? According to what we've drawn here.
No, it just like touches it.
No, and that's what that means, is ever below. Yes, it could equal it, but no, it's never below.
Okay.
All right, I'm going to send you the notes here right away. We'll change to my system, but you'll get them right away here. And I appreciate you scheduling. I'm sorry this wasn't more clear, but if you understand this, you're definitely going to do great on your test.
Yeah, it helped out a lot. Thanks, Matt.
You're welcome. Have a great night. Bye now.
You too. Bye-bye.